We've finally reached our last topic in this unit, 23 days in. All right, so today we are talking about something called the change of base rule. Okay, and this is just a property that you can change a log from one particular base to any other base that you want. Okay, so when we look at this property right here, so you've got some log, b is the base number, and a is your argument, right? So you can rewrite this as a log of some other number c. So c wasn't in the original problem. You get to choose what c is. So it's a log base c of whatever the argument was divided by log of the same new number c that you chose of the base. Okay, so it lets you split it, and you can do that with any base number you want. So you could use a log base 10 if you wanted just a regular old log, right? Or you could do any other number that you want that might be useful to you. Okay, so it's pretty cool. So the first thing that I want to look at with this example is I want to look at where does this come from? Okay, so where does this come from? How do we know that it works? Okay, so we're going to do like a little mini proof here. Okay, so first off, we're going to do this whole pretend this equals x. Okay, and then we're going to change our form. So little number becomes the big number, a number on the outside wants a friend, stuff in the middle wants to be left alone. Okay, great. So we know how to do that. So now I'm going to take the log of both sides as though I'm trying to solve for x. Okay, so what our goal here is going to be is that we have this thing that we set as equal to x. I'm going to rework it, solve for x again. And if I can figure out what x equals from that, it will have to equal what this thing was. So I'm going to take the log of both sides, and I'll go ahead and drop that exponent while I'm at it. Okay, and then, right, when we do that log of both sides, right, we took the log of both sides. You could have done it with any base. I just chose a log base 10, but you could have done it with any base number. So for this step right here, right, you could have used any base. Right, and we kind of talked about that when we were taking logs to solve, right? So we talked about how, like, if you have, oh, say 5 to the x equals 8, right? You could take a log base 5 of both sides, right? Instead of just a regular log, so that these cancel out and you get x equals log base 5 of 8, right? And then put it in your calculator that way. So you can use whatever base number you want as long as it's the same on both sides. Okay, so then from there, to get the x by itself, I would just divide both sides, and I'd have log of 12 divided by log of 4. And remember, that's not the same as the log of 3. Okay, that's not a property of exponents. We have a property that says if you're subtracting two logs, you can divide the arguments, but we don't have any kind of properties about dividing two logs. Okay, so now we've solved for x, and what does that mean? Well, up here, right, at the very top, we started by saying that this was what x equals. And now down here, we're saying that this is what x equals, right? So because both of these two things both equal x, right? There's a transitive property of algebra that says that these two must be equal to each other. Okay? And because we could have used any base, we could have done the same proof with any other number here. Okay, and that is where this property comes from and why it works. Okay, great. So let's take a look at some of these in action. So as an example, this guy right here, I can rewrite this as the log of any base number you want. I'm going to stick with base 10 of 73 divided by the log of 15. Okay, so it's always the log of the larger sized number, the larger font size, divided by the log of the smaller font size, if you will. So log of argument divided by log of base. Okay, great. All right, so let's take a look at this next guy. So this one, I've got these two logs, and you notice how they have the same base number, right? So I can actually use this property backwards. I can start from here and say, let me combine this together into one log. So I can rewrite this as the log, right? And it's always the log of the argument over the base. So the log of the argument over the log of the base. So 8 has to be the argument, and 16 would be the base. Okay, and now this is something that I can solve. So if we think about like, pretend that this equals x, I can convert this and say it would be 16 to what power equals 8? And let's see, those are both powers of 2. So this is 2 to the 4th, and that's 2 to the 3rd. And now since they have the same base, I know that this has to equal this. So 4x equals 3 and x equals 3/4. And now we have fully simplified this log without using any kind of calculators or anything like that. Okay, so this is where the change of base rule is helpful. Okay, this guy right here. So again, they have the same base number and it's pi, which I don't want to deal with pi. So I can combine this into one log, and it's the log of the argument over the log of the base. So this is going to be the log of base 25 of 5. Okay, and then take kind of the same tactic. If I rewrite this, we're looking for 25 to what power equals 5? Well, I have to square root 25 to get to 5, right? So that would just be the 1/2 power. If you couldn't get that in your head, rewrite this as 5 to the 2nd, and then that would have to equal 1, right? And solve it from there. All right, next guy. This one has a log with a decimal base number, which gross. So I can combine this together, and it's log of argument over log of base. So this would be log base 9 of 27. Okay, same deal. Pretend it equals x. I want to know 9 to what power equals 27. Those are both powers of 3. So that's 3 squared to the x power equals 3 to the 3rd power. So 2x equals 3 and x equals 3/2. And there we go. Lovely. Okay, so that's how we can use this kind of basically to simplify stuff. So let's take a look at these problems at the bottom now. So these ones are a little bit complicated. Okay, we have a property that says, like, the only time we've really ever multiplied logs, right, is we had that one property that said that if the argument and the base are the same but switched for both of them, that they multiply to 1. So like if this was log base 8 of 25 times log base 25 of 8, it would cancel to 1. Okay, but since it's not, we can't use that property. So what I'm going to do instead is I'm going to use this change of base rule and see where that gets us. So this guy I can rewrite as the log of 25 over the log of 8. Okay, and we're multiplying that by this guy, which I can rewrite as the log of 4 over the log of 125. Okay, so now what I'm going to do is I'm going to see just how much I can simplify these. So I'm noticing that some of these arguments are powers of another number. So I'm going to go ahead and rewrite those as powers of a number. So like 25 is 5 squared, right? So I have that as log of 5. And then since it's 5 squared, I can drop that 2 down into the front, right? Okay, log of 8. So that is the log of 2 to the 3rd power. But again, I can drop that down into the front. So I'm going to go ahead and do that. Okay, log of 4 is 2 squared. So 2, and then I'll drop the squared down in the front. And 125, that is 5 to the 3rd power. So that's a log of 5, and I'll drop the 3 down in the front. And now we're multiplying two fractions, right? And there's a property of fractions when you're multiplying them that you can do that cross cancellation thing. So since the log of 5 is a common factor on a diagonal, I can cancel that out, right? Because that's just 2 times the log of 5. Those don't have to stay together. They're just being multiplied together, right? And this whole thing's a multiplication problem. And then similarly, I've got a log of 2 and a log of 2. Those will cancel each other out. So all I'm left with is 2 times 2 on the top and 3 times 3 on the bottom. And that is fully simplified, which is kind of nice. I find these problems sort of satisfying. All right, so same deal with this guy. This time we're going to have 3 fractions, right? So I can rewrite this as the log of 5 over the log of 36. And then this one is the log of 8 over the log of 25. And then this one's the log of 6 over the log of 4. Okay, so from here, I'm going to rewrite these as power. So log of 5, that's not a power of anything, so that's done. 36 is 6 squared, so I can make it log of 6 and then drop the 2 in the front. 8 is 2 to the third, so I can make it log of 2 and then drop the 3 in the front. 25 is 5 squared, drop the 2 in the front. The log of 6, that doesn't break down at all into powers, but the log of 4, that's 2 squared. And I'll drop the 2 in the front. Okay, and then you're looking for anything on a diagonal that cancels. Okay, so like I've got a log of 5 here and a log of 5 there, so those will cancel each other out. I have a log of 6 on the bottom and a log of 6 on the top, so those will cancel each other out. I have a log of 2 on the top and a log of 2 on the bottom, so those will cancel each other out. And I believe that's it. So that leaves me with just a 3 on the top, and on the bottom, 2 times 2 times 2 is 8. And that's fully simplified. All right, last one. So this one's got letters. So this one's going to be a bit of an adventure. So I can rewrite this as the log of A over the log of C to the third. But since I'm here, I might as well drop that 3 in the front, right? Okay, and then this guy I can rewrite as the log of B to the fourth, but again, let me just drop that 4 in the front. Over the log of A squared, drop the 2 in the front. And then times the log of C, and then the log of B to the fifth, which I'll drop in the front. Okay, and let's see what we have that'll cancel. This log of A will cancel with that log of A. This log of B will cancel with that log of B. This log of C will cancel with that log of C. So what are we left with? Oh, I've got a 4 and a 2 here. I can cancel a common factor from those, right? So 2 goes into both of those, so I can simplify that to a 2 and cancel that out. So I'm left with just a 2 in the top, and then on the bottom, I've got a 3 times 5, so 15. So that is that expression fully simplified. So I kind of like those ones. I find them kind of satisfying. I really like problems where I just easily rewrite something and then lots of things cancel to give me a really easy answer at the end. Okay, so that is your change of base rule. The big thing that you just need to remember with it is you got to remember what order they go in. Okay, so remember that the argument's always on the top and the base is in the bottom. Okay, so remember that one thing and then just keep an eye out for when you need these types of problems.